Now in this tutorial, what I want to do is show you how we can work out the exact values without the use of a calculator of the tan, cos and sine of 45 degrees. And to do this, what I'm going to encourage you to do is learn this particular triangle. Learn the ratio of the sides as being 1 is to 1 is to root 2. But before we start, I'm going to show you how we get this result. So let's step back for a moment. Okay, we'll remove the triangle, and what we'll do is we'll look at a square. Now obviously with a square all the sides are exactly the same length, and so if I was to draw a diagonal through here, what it's going to do is it's going to cut this angle of 90 degrees in half. This is going to be 45 degrees, and this angle up here is going to be 45 degrees, and we're obviously going to have a right angle here. So what we've essentially got is this diagram. Now with any square the sides are obviously exactly the same length. So let's suppose this length here was 1 unit long, 1 centimetre, 1 metre, whatever, but 1 unit long. Then obviously this side is going to be 1 unit long. So if I transfer this over to this diagram, we've got our sides here of being 1 unit. Now if we're to find the tan of 45 degrees, you should know a rule or rhyme often known as SOHCAHTOA. SOHCAHTOA for short spelt SOH, then CAH and TOA. And this is short for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So if I was finding, for instance, the tangent or tan of 45 degrees, then I'm going to need to compare the opposite side with the adjacent in this particular trig ratio. So if I take this triangle, which side is the opposite to 45 degrees? Well, if I concentrate on this 45 degrees, then this one over here would be the opposite side. And the side opposite the right angle is often called the hypotenuse, so we'll label that as H. And the remaining side is the adjacent side. So when it comes to tan of 45 degrees, which compares opposite over adjacent, what we get is the opposite 1 over the adjacent is 1. 1 divided by 1. And what's that as an exact value? Well, it's 1. So we have the tan of 45 degrees is 1. And you can check that out on your calculator. Make sure your calculator is in degrees mode, type in tan of 45 degrees, and you should find you get 1. Now when it comes to the cosine of 45 degrees, we've got that the cosine compares adjacent with hypotenuse. So if we're using this 45 degrees, the adjacent side would be the 1, but unfortunately we haven't got the hypotenuse. So what is that going to be? Well, if we were to call this x, we can work it out through Pythagoras' theorem, because we know two sides of the triangle and we're trying to work out the hypotenuse. And just as a reminder, by Pythagoras' theorem we would have that the hypotenuse squared, which is x squared, is equal to the sum of the squares of the other two shorter sides. So that's 1 squared plus 1 squared. So in other words, x squared equals 1 plus 1, which is 2. And if we square root both sides, x is the square root of 2. Now I'm going to leave it as the square root of 2 because if you were to work that out on a calculator, the calculator would only give a partial display of what the value is. It's an infinitely long non-recurring decimal, a rational number. So we'd never be able to give the exact value if we try to write it down as a decimal. So we'll leave it as root 2. And we'll update our diagram here with root 2. That's the hypotenuse then. So when it comes on to the cosine of 45 degrees now, cosine always compares the adjacent side with the hypotenuse. So if I'm using this 45 degrees, the adjacent side is 1 and the hypotenuse is root 2. So we get 1 over root 2. And when it comes to sine of 45 degrees, Sine compares opposite with hypotenuse. So the opposite side would be 1, hypotenuse root 2, and you get the same answer as you had for the cosine of 45 degrees. So we have 1 over root 2 for both these results. Now if you were to check these on a calculator that worked in exact values, you'd find that they have rationalised these. That is, they've got rid of the root 2 from the denominator here by timesing top and bottom of the fraction by root 2. And what that gives you is 1 times root 2 is root 2, and root 2 times root 2 is 2. And obviously that's going to be the same result there. But I'd encourage you nonetheless to learn these results as they come from this triangle. I'll just draw up that triangle again. That's where we started, remember? I said to you that I would encourage you to try and remember this triangle so that once you use this triangle you can then work out, providing you know these ratios here, you should be able to work out what sine, cos or tan of 45 degrees is without really having to commit to memory all these values. One other point I'd like to mention as well, it doesn't matter obviously which of these two 45 degrees you use, because if you took this triangle and we're using this one, then hypotenuse stays the same, but this becomes the opposite, that becomes the adjacent. I'll leave it to you to check it out all over again, but you'll end up with exactly the same results. Now why would I want to know these results? Well, in later tutorials what I'm going to show you is that we can find the exact values without a calculator of multiples of angles of 45 degrees. Like for instance 135 degrees, which is going to be a multiple of the 45 degrees. I could find the exact value out by using the quadrant rule and these values. Well, that's going to be handled, as I say, in a later tutorial, but I hope you can follow what I've done so far.